Welcome. In this video, I'm going to take a look at just kind of the big picture of data for a second, and then we'll zoom in on looking at variation. So really, when you're looking at a data set, there's kind of three kind of groups or ideas that we can think about. And the first is central tendency, and that's kind of where's the center of the data? What does that look like? The second is position, and that's if I look at a specific data point, where is it in comparison to the rest of the data? And the third is looking at variation, looking at how the data varies or how spread out it is. So central tendency is really looking at mean, median, and mode. We've talked about those, fairly comfortable. I don't think I'm going to review them here. Measures of position is really looking at quartiles or percentiles. So looking at the data and, if I have a certain percentile, say the 23rd percentile, then that means 23% of the data is below that point, and the rest is above. Or if we're looking at quartiles, the first quartile would correspond to 25% of the data below. So that's measures of position. We've looked at that. And then here, we're going to look at, which is probably one of the more interesting in my opinion, is measuring variation. How do you measure how spread out something is? Actually, you've probably looked at it in middle school, definitely high school, is range. And this is a measure of variation. And this is just taking the largest data value minus the smallest data value. And so we can say the data ranges from, 2 to 17. So the range is 15. So if I have a list of values where 2 is the smallest and 17 is the largest, to find the range, I would take 17 minus 2 is 15. The issue with the range is it's really affected by just two values. So it doesn't take into account what the rest of the data looks like. Is all the rest of the data smack in the middle, or do we have half 2s and half 17s? We can't tell from the range. It seems like in my experience that mean absolute deviation is kind of gaining popularity since 2010, the Common Core standards, but that's just my kind of experience and opinion. At least for middle school students, it seems like mean absolute deviation is a little bit easier to get your brain around than standard deviation. Mean absolute deviation is really just the average distance that values are from the mean. So if we take the distance a single value is from the mean, we can understand that. And then if we take all of those distances and we average them, that's what mean absolute deviation is. Okay? It weighs each value more or less equally, depending on where it is from the mean. Standard deviation, though, is a little bit more complicated. It more heavily weighs extreme values, and we're not going to get into that in this course, but I want you to know it exists, and it's kind of related to mean absolute deviation. It's really finding the square root of the average distances squared each value is from the mean. And that's a little bit fuzzy. It's not exact. There's a formula we can follow. But really the key is that it more heavily weighs those extreme values that are really low or really high. And then sometimes you also hear the word variation connected to measuring variation. And when they're using that as a specific measurement, they're referring to standard deviation squared. Okay? So like I said, we're going to focus on mean absolute deviation here. So I think I'm going to conclude this video and then start a new video on actually calculating the mean absolute deviation. So I'll close with that.